In this video, we're going to take a look at factoring quadratics. The key to being able to factor quadratics is this idea, the zero product property. If we can take a standard form quadratic like this guy and rewrite it so that instead of adding terms together, we're multiplying terms together, then we can use this property to solve each factor. If things are multiplied together and giving us zero, then one of them has to be zero, at least one of them. Okay, so I like to use the diamond method to help me organize my thoughts as I am trying to factor this. So I want to know where are the solutions or the roots of our quadratic. So I'm going to make my output equal to 0 because that's what I'm looking for. When y is 0, we hit the x-axis. So I've got x squared plus 5x minus 24. Okay, so what I'm going to do is I'm going to take the numbers in my quadratic, my coefficients here, and I'm going to put them in this little x puzzle. So on top, I'm going to put in the c value, negative 24. So negative 24 goes on top. And then on the bottom, we're going to put in the linear coefficient, this time being 5. So b goes on the bottom, and then c goes on top. You might see over here that we're actually going to multiply a and c together, but we'll talk about that in just a minute. Right now, a is 1x squared, so we're just going to ignore that for a minute. Okay, so now my job is to think through all the factors of 24 and see if I can get them to combine to add up to 5. So you might think through your factors like this, 1 times 24, 2 times 12, and so on. Looks like 3 times 8 is going to work. So I'm going to throw in those two numbers, 8 and 3. But notice I need to multiply to get negative 24. So one of these has to be negative, and if we're adding up to positive 5, that has to be 3. Okay, so now I have the numbers needed to turn this into factored form. So I know I have x times x to give me the x squared part, and then I'll have positive 8 and negative 3. Okay, so I've successfully taken a standard form and turned it into a factored form. Now that we have two things multiplied together equal to 0, we're going to use that zero product property, which says one of these, or at least one of these, has to be 0. So we could say x plus 8 is 0, or maybe x minus 3 is 0. These are the two situations that solve the equation. So the two answers we have are negative 8 and 3. You can graph this in Desmos to prove we touch the x-axis at negative 8 and at 3. Okay, for a slightly more complicated problem, we're going to jump over here. This time we do have an a value that is not 1. So remember earlier I said we put c on top? That's not really true. We put a times c on top. Just most of the time we don't have to worry about a. But let's try this out. We've got 3x squared plus 10x minus 8. Notice I've gone ahead and set this equal to 0 because we're looking for the zeros of the function. Okay. So I'm going to do my x puzzle over here. It's going to look a little different here. So on top, I'm going to do a, which is 3, times c. So that's negative 24 on top because it's 3 times negative 8. And then on the bottom is b, just like it was before. So that's just going to be 10. Okay, so now I've got to figure out factors of 24 that add up to 10. And again, we can think through our factors. I've already got them over here. I think 2 and 12 should do the trick, or maybe 4 and 6. Ooh, this one's tricky, so I'm going to think about it. I need them to be different signs, so I want a difference of 10 in order for this to multiply, give me a negative. Okay, so we're going to go with 2 and 12, but these are not our factors. A, because this one needs to be negative. Now it works. 12 times negative 2 is negative 24, and then 12 minus 2 is 10. Now, because we had to multiply times a here, what we really want to put on the sides of our puzzle here is our factors, whatever numbers we get, divided by a. Again, in most situations, like this first one, a is 1, so we just ignore that. But in this situation, I actually did have an a value that I needed to slide there. So I'm actually going to put both of these over 3. Now I'm going to continue factoring. So I've got my factored form here. So this is going to look a little different. So negative 2/3. This will be x minus 2/3. And that's not a great way to write a factor. We'll come back to that in a second. Over here I have 12 over 3, so that's just 4. That one we can write out, and that's actually done. Now, it's not proper form to leave a fraction in factored form. Although we can easily see what our answer is, the root is 2/3, usually in factored form we don't include fractions. So what I'm going to do instead is I'm going to take this number and slide it up to make this proper factored form. So instead of saying x minus 2/3, I'm going to say 3x minus 2. These are the same thing, right? 3x minus 2 is 0. It's the same exact thing as saying x minus 2/3 is 0. If you don't believe me, you can divide everything by 3 there and check it out for yourself. Okay, so here is our proper factored form. 3x minus 2 times x plus 4. And I am way better at doing distribution forward than factoring in reverse here, so I like to check my work. 3x times x is 3x squared. We get 12x minus 2x, so that's 10. And then lastly, we get negative 2 times 4, that's 8. So it looks like we did this right. Now the last thing, we still need to solve this using our zero product property. So we'll take each piece. You've got 3x equals 2, so x must be 2/3, just like we saw earlier. And on this side, this one's a little easier. You can do this one without writing it out, but we get negative 4. So there's our two solutions, 2/3 and negative